Hello everyone and welcome to today's webinar. Thank you all for finding the time and joining us for the second webinar organized by GPBM Industry. Today, we will be presenting primary batteries in IoT applications. I will be the main speaker. My name is Anas and I am the Industrial Sales Manager of GPBM Industry in France. I have an engineering background in electronics and embedded systems, and I have been working in the energy management since over a decade. I am located in Paris, and the weather is wonderful here today, by the way. I will also be joined by my colleague, Siddharth, who is the product manager of GPBM Industry. He has also an engineering background in energy management, and he is located in Sweden. For this webinar, we will have a special guest, Dr. Wilfried Drahn, the CEO of WiseBat, a leading company in the simulation of battery behavior in embedded systems, and especially in IoT applications. Thank you, Wilfried, for joining us for today's webinar.
Thank you very much, and hello, everyone.
Thank you, Wilfried. So, as I said, today we will be presenting primary batteries in IoT applications. But before starting the presentation, I will take 1 or 2 minutes to do a brief introduction to allow time for the other attendees to log in. We will start by introducing our company. After that, we will talk about the primary batteries and answer some of the frequently asked questions that we get from the field. Then we will talk about using WiseBat, a modern simulation tool in the IoT for IoT projects. At the end, we will have a Q&A session as usual. So we are GPBM Industry, a division of GPBM Nordic, a battery supplier and a member of GP Batteries Group. We are a European company with offices and warehouses located in Scandinavia, France, and Italy. As a battery specialist, we offer a broad assortment of primary and rechargeable batteries for industrial applications. We have the engineering resources to fulfill specific demands for custom design battery packs. We also support our customers in all the project phases from the pre-study to mass production. We have a sister company in our group named Exo Industry, who has a production line located in France dedicated to customized battery packs. We commit to comply with safety standards and regulations, and we make sure to always provide our customers a constant level of performance and quality. We are adopting advanced battery technologies to provide safe and reliable batteries to serve your projects within the Internet of Things universe. As we said last time during the first webinar, batteries are everywhere, especially primary batteries. If we take a typical house as an example, we will find batteries in several consumer devices that we use in our daily life. For example, we will find the AAA alkaline batteries and coin cells in the remote controls, the CR123A and 9V in the smoke detectors, and the AA lithium thionyl chloride batteries or CR123A in motion sensors, AA alkaline batteries or manganese dioxide batteries in smart locks, and the list is very long. Even if some batteries may look the same or have the same shape or same size or same brand, each battery has its own characteristics, such as voltage, rate capability, energy density, and operating temperature. So the first question that comes to mind is when to choose a primary battery. As a true believer in a safer and greener today and tomorrow, we are always putting priority on sustainability and ecological footprint. Naturally, we will always favor rechargeable batteries that can be recharged and reused several times. But this is not always possible, especially for applications with low accessibility and when it is not possible to recharge the battery. Maintenance is also one of the criteria that can push the customers to choose primary batteries because they are easy and we are used to replace them. The third parameter is temperature because primary batteries have a wider operating temperature range, which is important in outdoor applications. Energy requirement is also very important because for the same size, primary batteries offer higher energy density, and this is very important for connected devices that require or have a very small size. Shelf life is also a very important criteria because primary batteries can be stored without maintenance, while rechargeable batteries must be recharged after a few months of storage. So when it comes to IoT applications, power management is a challenge of particular interest to electronics engineers. The key requirements for such applications are speed and the distance. Both are proportional to the power consumption. For instance, satellite, Wi-Fi, or wide area networks like 4G or 5G are used for the transmission of big amounts of data at high speed, which is not convenient and suitable for devices running on a primary battery. But ZigBee or Bluetooth or BLE Bluetooth Low Energy are used for short distance communication at a low to medium speed. So they are more suitable for personal area network in applications like smart homes. But IoT is about creating low power objects capable to emit small amounts of data on an average range of about 30 kilometers. And this requires having a smart power management. Protocols such as Sigfox or LoRa offer a good balance between power and network efficiency. Therefore, they are suitable for smart cities projects, for example. So optimizing the use of battery to limit the power consumption and avoid the costs of maintenance and battery replacements must be considered at the early stage of the project. And modern simulation tools like WiseBats allow us to set and test several strategies at the early stage of the project. So what are the main requirements for IoT applications? So the first one is safety, of course, because we would like to have a safe device, not causing any issues to the environment or to the users. Internal resistance is also a very important requirement because it can create voltage drop and it can turn off the device if we reach the threshold of minimum voltage. We have also the cost because the aim is to duplicate the number of IoT sensors and devices. So it should be, and it must be cost efficient, lightweight, miniature size, because we are talking about small devices and small sensors. Environmental conditions and temperature are very important because we use these devices outside. Then we have the shelf life because these batteries, these devices should be stored for a long period before being used. Voltage stability, because if we can use the device without having a DC converter can help us have a better efficiency and also save the cost of a few components. And of course, power efficiency, because we would like to use every single microwatt hour in the battery. So what are the most common or most known primary chemistry platforms? So the first one is alkaline batteries. So these batteries are used for consumer devices. So we all know these batteries because we use them for our remote controls, for example. They are suitable for indoor high drain applications, but they offer a very limited temperature range. The next technology is lithium manganese dioxide. This technology offers a bigger temperature range. They are recommended for consumer devices and ideal for IoT applications or IoT devices. For example, like smart homes for cameras or smart locks, and they can deliver a high current in discharge, but they have low specific energy compared to lithium thionyl chloride. And lithium thionyl chloride offer a very extended temperature range compared to lithium manganese dioxide, an extended shelf life, but can only accept low to moderate discharge currents. The last one is lithium iron disulfide that has 1.5 volt, which is compatible with the alkaline batteries, They are suitable for moderate to heavy loads, but they are not suitable for applications with low discharge rates. So in this slide, we will show you some characteristics of the technologies that we have explained in the previous slide. So the first one is the nominal voltage. So as you can see, each technology has its own nominal voltage. So the nominal voltage for a primary battery is the starting point when the battery is fresh. So for lithium tungsten chloride, it's 3.6 volt, lithium manganese dioxide, it's 3 volt. And for the two other technologies is 1.5 volt. For the operating temperature range, we have a bigger or extended temperature range for lithium tungsten chloride from minus 55 degrees Celsius to plus 85 degrees Celsius. A lower temperature range for lithium dioxide, manganese dioxide, and a smaller for the two other technologies. And for the energy density, of course, we see that lithium tungsten chloride have a bigger and higher energy density. But as we said during the first webinar, it doesn't mean that lithium tungsten chloride is better than the others, or that lithium manganese dioxide is better than lithium tungsten chloride. We should always not only take into account energy density or only capacity, we should consider all the characteristics and all the parameters of the battery and see if they match with the requirements of the application and of the project. So does voltage stability matter? We get this question a lot from the field. Because if we take, for example, the curve on the left, the orange one, of lithium manganese dioxide battery, we see that the curve is during the discharge, the voltage will decrease smoothly, and this will offer an easy way to predict the end of life of the battery by just measuring the voltage of the battery. For lithium tungsten chloride batteries, we will have it's the green curve. It offers a flat voltage curve, and this will the benefit of this technology is to be able to use it directly to power the electronic ICs without using a DC-DC converter. So it doesn't mean that one technology is better than the other. It means just that one can with one we can easily predict the end of life, and with the other one we can have a stable voltage and we don't need a DC-DC converter, and we can save a few components on the electronic board. So yeah, we talked about voltage stability, but there is also one other parameter which is very important for IoT applications, and it's performance over the time. Because even though if we would like the voltage to be stable, we would like to have a stable voltage when the battery is fresh and also at the end of life of the battery. So here in this curve, we are comparing three brands of CR123A. So the orange one is from GP batteries, and it's as you can see, the orange curve is decreasing smoothly, and there is no change or big change in the voltage during the discharge phase. While we see that brand 1 and brand 2, the voltage will suddenly drop. And this, with such phenomenon, if you discharge at low discharge rate, you may lose the capability to predict the end of life, because you are expecting the battery to be empty maybe in 1 week or 2 weeks. So you can't notify the customer that the battery is, for example, at 10 or 20%, and it will suddenly drop, and you can't predict the end of life. So for our GPCR123A batteries, we comply with all the safety standards. We have a true stable voltage curve for even at low drain discharge rate. It's a spiral construction, which allows to have and accept and deliver high drains for example, applications having several communication protocols. It uses a non-explosive electrolyte. It has a safety vent, and all our CR123A batteries are equipped with an internal PTC to protect them from over discharge. So pulse management is also one of the challenges of IoT applications, because during the transmission we have to manage the pulses of the transmission. So the pulse value and frequency should be taken into account and measured very well, and it depends on several parameters of the electronics design and or the type of components you are using. And the average discharge current will have a direct impact on the capacity, and the pulse value will have a huge impact on the voltage drop. So it's important to be able to measure and to know the value of this pulse and to manage it with a good strategy to predict all behavior of the battery. So if a general type lithium chloride battery is not enough to manage the pulse, we can use a pulse type batteries, or we can also add a supercapacitor or a capacitor to support the battery. And if it's not enough, we can switch to a spiral construction type or to a lithium manganese dioxide battery. So battery packs, we see more and more applications in IoT universe requiring a higher energy. So we have to assemble batteries in series and in parallel. But doing that requires adding some safety components to protect the battery pack. So for example, we will add a fuse to protect the battery pack from short circuits. We will also add blocking diodes, the orange diodes, to protect the battery pack from being accidentally recharged. And we also add the bypass diodes to protect the cells from being forced at a forced discharge. As we said at the beginning, certification and quality are very important for GPBM industry. So as you can see here on the picture on the left, this is a photo of our alkaline battery in China. It's a fully automatic production line that can produce over 150 batteries per second. And in this factory, we follow all the international standards for safety and for quality and for the standards and all the standards of battery. So when you choose a battery or a partner to work with for your projects, it's always very important to choose a partner who is following and complying with all the quality standards, and also make sure that the batteries are compliant and certified for example, transportation, safety, and the standards like IEC 60086. So we will show you here a few examples of some applications that we are working on with some of our customers. So the first one is from NKE Wateco, one of our customers located in France. So this device is a connected device to maximize the industrial performance. So they have several sensors on this connected device, a temperature sensor, vibration sensor, a tilt sensor, and a gyroscope. This IoT device is using LoRaWAN, and it can operate in a temperature range going from -30 degrees Celsius to +70 degrees Celsius. We are offering a lithium thionyl chloride battery, a size with a spiral construction with 2 amp hour capacity for this product. And please feel free to visit the website of NKE Wateco and get in contact with them if you would like to know more about this product. The next one is a tiltmeter used for smart cities. It's designed and manufactured by Semantis, a French company. So this smart device is measuring and monitoring the deformation and the stability of the buildings and infrastructures. It communicates on LoRa network. And we are delivering lithium thionyl chloride batteries from our partner Xeno, and it's a D-size batteries in a bobbin construction with 19 amp hour capacity. And of course, you can go on the website of Semantis to know more about this product. So now we will talk about WiseBat. So I will now pass the mic to the CEO of WiseBat, Dr. Wilfried John.
Hello everyone, thank you very much Anas for this kind introduction. So I'm the CEO and co-founder of WiseBats, and what we wanted to build with WiseBats was a way to provide critical insights to hardware engineers which are not familiar with the specificities and the chemical properties of batteries right at the beginning of the design cycle. So we designed simulation tool that is based on scientific research that was achieved here in Paris. And to give you a few word about that, it's around 8,000 models that you can use from more than 100 silicon vendors, so electronic component manufacturer, and that's based on a patented technology. And the most important is that the result of the simulation tool were validated by more than 200 real life experiments. So the platform itself is able to cover, of course, not everything that you could cover with real life experience, but at least the most important point, we are taking into account internal resistance, voltage simulation and stability, safety aspects, of course, power efficiency and also energy density, as you can compare different chemistry within the tool, and the cost. I didn't mention it, but that's a tool that is available through a browser. And yeah, to give you an idea of where we are sitting within this huge value chain. So here on the screen, you have a short representation or a simplified representation of a product cycle going from the ID to the product validation, and you can count on 5 steps more or less. So you get the specification phase, then the actual design, then testing and validating that the design is what you wanted to do, then the sourcing, even though the sourcing can begin earlier in the design cycle, and then you go onto the pre-series. So within this value chain, we are sitting right at the beginning. One of our biggest competitor, as a lot of people may know here, is Excel. So the computation that we are providing used to be achieved in Excel, and we are trying to bring as much value and as much information as we can earlier in the design cycle, by, for instance, partnering with GPBM and providing price insights or technology information about their product right at the ideation stage. So the easiest way to demonstrate what we are able to do is to go through a live demo. So for this specific demonstration, I used an example of GPS asset tracker. Obviously, I won't do the design with you, but just demonstrating it. That's on Sigfox network, and we have one transmission every 2 days with an expected service life around 5 years, and the temperature range is between -40 and +85 degrees. So the battery element, so that's the platform. The battery element we choose to demonstrate for this is an element from Zeno Energy, the XL055F. So you can find all the information as Anas mentioned on Zeno website here, and there is also the datasheet, and that's I use it on purpose here. So the idea is to turn this datasheet into something more usable within the tool. So in the schematics parts, we have the hardware configuration, which is simplified in our tool, since this is an exploration tool. So basically what we have here is a microcontroller. We have an accelerometer and GPS sensor. So each time there's a tilt on the device, the GPS position is sensed. We could use this scenario. Then we have the Sigfox radio here, and we already did the work to optimize power consumption, and we can talk about that in the Q&A section, but we already did the work by load switching all the heavy elements like the GPS and the Sigfox radio, and by splitting power rail within two different regulators that get their efficiency points right at the sweet spot for the power consumption of the two parts of the circuits. So the tool is fairly simple. I described the schematics, but what you can find on the right here is a library with all the component model. So for each model, you're gonna have a first level of information here. Then you will be able to browse the data. Adding a component on the design space is fairly simple. This is only a drag and drop. So that's made really easy. Once you describe your hardware, we can go to the behavior part, which is probably one of the most interesting one, since having all the components and the power consumption is not enough to describe the behavior of your device. So in this case, that's a big behavior here, but that's just for the sake of the demo. You're gonna have a library here where you will be able to use what we call states, and those states represent what the electronic component can do. So basically, here, for instance, I'm able to say that each 8 hours, I'm going to sense the data out of my accelerometers, sense data, get the position, from my GPS, and then after 2 days, sending all the information through the Sigfox network here. So I'm going very quickly through this. As I mentioned, we can talk about that. But the idea is that with this behavior, we can describe the way the device will behave dynamically through its life. And once we've done the hardware part and the behavioral part, we will be able to launch the simulation. So in this case, that will be fairly quick. That should take 10 to 15 seconds. Sometimes it can take a couple of minutes, but the result will be the same. So we are providing 4 types of results with the tool. That's the first tab, overall result. In this tab, we find several key information. So for instance, the battery life. As I mentioned, we were expecting 5 years. We are completely within the spec of our expectations. We have cost of production estimation, and I will come back to that later. And then we have warning if we have some error or warnings that we should pay attention on the design space. Then we have the electrical characteristics. So we generate a table with all the electrical characteristics of each component. As I mentioned, all the datasheets are able through those links here. And this is a handy way for engineers to just download this table and start from there. So that's for the overall results. And of course, we also have the battery characteristic here. Then going to the power analysis, which is the thing that's the most interesting for us today, we are going to find back the battery life estimated here. And then the first information that we are going to have here is a consumption distribution. This consumption distribution allows me to know where am I spending the power within my device. So this is a very important information because, for instance, in this case, we have 5 years of battery life. Then we can notice that we are spending 40% of power into conditioning the power stage. Further, we are going to find supply voltage curve and current draw curve. So if I'm doing a very, very quick zoom here, we are going to see roughly the voltage drop each time we are on activity within our device. And then the same way I can zoom on the current draw and see how am I consuming, how my electronic components are consuming current from the battery. If I want to go further, I can go further by clicking on components. This will allow me to see, in addition here on the side, how much time and energy I'm spending in each stage of the component. So I can go very deeply into understanding how the component is behaving. Last two tabs are going to be cost of production. So once we are okay with the power consumption and battery life, we can have a look at the cost. Of course, that is not the final cost that you may be able to negotiate, but that's a rough idea of how much the BOM, so the bill of material, is going to cost. And this is an important information when we are making design decision. So that's why we include it here. And we are basically sourcing the cost on more than 180 distributors in Europe, North America, and Asia. And then the final step is going to be the design file. So here we are allowing hardware engineers to download an archive with all the parameters and configuration of each of their components. So for instance, if I click on my microcontroller here, I'm going to see through which peripheral it is connected, as well as its configuration here, which might be pretty intense on the screen, but that's really handy information when it comes to designing the firmware. So that's for the main feature of the tool. And as any tool, we also have a live support. So you're gonna find a small here pop-up, and that's really me answering the question most of the time. But if you are lost, or if you have any question that may be technical, or about the tool, or about the components that are modeled within the tool, our users and customers used to use this intercom window to reach out to us. If we can manage the technical request, then we handle it. Otherwise, we imply the manufacturer in order to get the support as quickly as possible. And I think that was it for me. So that was for the demonstration. If you want to get more information about that, you can visit our website at www.wisebat.com or reach out through the chat, and we'll be pleased to answer.
All right. Thank you, Wilfred, and thank you, Anas, for the presentation. This is the end of our presentation round. So now we are going to the Q&A. One question for you, Wilfred. The question is, does WiseBat work only when the relevant hardware is connected to it?
So that's purely simulation based, which means that you don't need to have any connected hardware beyond the selecting the components model from the library. That's purely based on simulation.
All right, great. And there's also a question of whether an evaluation version of the tool is available or not for you, Wilfred.
Of course, so you can benefit from a 15 days or 2 weeks trial that we have on our websites, or you can reach out to us if you have bigger project or student project or research oriented project, then we can provide you with a longer evaluation version.
Thank you, Wilfred. All right, we have a new question here. I think this is for Anas, maybe. Does any of the batteries mentioned above consist of an inbuilt BMS?
Actually, it will depend, because as we said, we will support our customers to find the right battery for their application. And if the application requires a BMS for safety reasons, then we will add an electronic board. And again, here we are talking about primary batteries, not rechargeable batteries. So the main safety components, as we said, will be bypass diodes and blocking diodes. We may have or find in some of the applications some components to estimate the remaining capacity or energy. But again, it depends on the needs of the customers, and we always make sure to provide you the right product to fit in your application and in your project.
All right, thanks, Anas. While we wait for new questions, there was a question about temperature range. for different chemistries. Anas, would you like to maybe talk about maybe the usage or storage conditions, etc.?
Of course. So as we said at the beginning, each technology has its own characteristics. And one of the characteristics is the temperature range for operating and for storage. The information about temperature range is always specified in the datasheet and in the specification. So we make sure always that the temperature range of the product or of the project is matching with the temperature range of the battery. And to always make sure that the customers are using the batteries within the limit of the specification. Again, temperature range is linked to the chemistry and to the electrical platform. And it doesn't mean that a technology is better than the other. It just means that each chemical platform has its own characteristics. Yeah.
Thanks, Anas, for that. Don't forget to follow us on social media. We are on LinkedIn and we are always updating. You will get to know more information about us and our activities there. So please do follow us there. You're also welcome to contact us for anything regarding this webinar or regarding any particular project or application. We are happy to assist you and answer your questions. Also, WiseBat. Wilfred is here and he will also be happy to help you if you have any questions for WiseBat. Please follow WiseBat on LinkedIn for their updates as well. And yes, we are going to continue this webinar series and we will be focusing on next webinar about rechargeable solutions for e-light applications. So this will be we'll be focusing a lot on other chemistries which are rechargeable, lithium and nickel metal hydride. Stay tuned for more information about this, and then you would get to know more information in your inbox when we fix the date and the time. And please come back and get to know more information. We have one question here. Well, it's more of an opinion. Thanks for a great seminar. We'll get in touch for any additional info. Thank you for that comment.
I can also indicate that in addition to the video, the project that I showed you during the demonstration will be also available and readable from the webinar users or from the people that are going to watch the replay of this webinar.
Thanks for that, Wilfred. Thank you for the participation. We hope that you got a lot of information today and will be able to apply them at your work, and hope to see you soon and hope to see you again in our next webinar. Yeah, thank you, Anas and Wilfred, for this as well.
Thank you for joining us today, and we will see you next time.
Thank you very much for inviting me and for joining us today.